All right, so we talked a little bit previously about whether something is going to sink or float based upon its density and the density of the fluid that it is in, okay? However, the reason it is sinking or floating is because of the forces that are acting on it. And one of these forces is the buoyant force, okay? The buoyant force is an upward force exerted on an object by a fluid. That means if an object is in a fluid like air, okay, remember air is a fluid, it's a gas, but gases are fluids, or water, okay, again, that's a liquid, but a liquid is also a type of fluid. There's a buoyant force on it, okay? So let's go ahead and let's take a look at an object that is submerged in air, okay? So let's take a look at a balloon, okay? So this balloon is submerged in air, and we're going to say it's a helium balloon. Well, it's either going to rise or it's going to sink, and that is going to be based upon the forces that are acting on it. So one force that's acting on this helium balloon is the gravitational force, okay? However, it is in a fluid. It's in air. Therefore, there is a buoyant force acting on this helium balloon. And that buoyant force is exerted upward. Okay, so there are two forces acting on the balloon. Now, if the buoyant force is greater than the weight or gravitational force, so if this force is bigger, well, then it's going to accelerate upward. It is going to rise. However, if the buoyant force is less than the gravitational force, okay, so this is smaller than the gravitational force, then the net force is going downward and the balloon will sink, okay? So we could have it rise, we could have it sink, and then we're missing the one in between. What if those two forces are equal? Well, to look at that one, I'm going to change it up a little bit, and we're going to go ahead and instead look at water. Okay, we're going to put an ice cube in water. Well, what do we say that ice cube is doing? It's not rising, it's not sinking, okay? It is floating. And that happens when the buoyant force is equal to the weight of the object, okay? Then the object will float. Okay, so let's take a little bit of a further look at this, okay? We've got this equation, this statement here. It's going to lead to our equation. The buoyant force is equal to the gravitational force of the displaced fluid. And this can be a little bit difficult to interpret. So we're going to look at a picture here. All right, so got this picture up here. The buoyant force is equal to the gravitational force. Another word for gravitational force is weight. The weight of the displaced fluid. So here I have 5 kilograms, okay? And on the scale, it's going to go ahead and read what it is. Go over here, place it in water. Now, it's not reading as much. Why? Because there's a buoyant force going upward. What is that buoyant force? Well, we have this beaker here filled to the brim and the little spout off to the edge. So if we stick this down inside, the water level is going to rise and the water is going to drain out into this container. Okay? What this says is the buoyant force is equal to the weight of the displaced fluid. This is the displaced fluid, the fluid that was displaced, that was moved out from the beaker. Okay? That is what this is. So whatever this is, I put it on the scale, I read it, that's the buoyant force. Okay? So it can be a little tricky to figure this out. Our equation's fairly simple. The buoyant force is equal to the mass of the fluid. This is the part that tricks people. Okay? The buoyant force is the mass of the displaced fluid. It's the mass of this times the gravitational field constant so that we can get the weight of the displaced fluid. But this is where oftentimes people put the wrong mass in. This is not the mass of the object. This is the mass of the displaced fluid. Okay? So a lot of times we don't know the mass of the displaced fluid. Instead, we know things like the density of air. Okay, so the balloon is in the air. The fluid that's displaced when you blow up the balloon with helium is air. It gets moved out of the way. All right, so we have to find the mass of that, and we often do that using the volume. Okay, so what volume do we use? Well, if an object is completely under the water, okay, then the volume of the displaced fluid is equal to the volume of the part of the object. So the volume of the displaced fluid is equal to the volume of the part of the object that is submerged. Okay? Now, if the entire object is sunk and it's underneath the water, okay, it's just sitting on the bottom, then the volume of the displaced fluid is equal to the volume of the object. However, if you have something like the ice cube that we had before, okay, then it's only this portion. That is the volume of the that is underneath that's submerged, therefore that's the volume of the fluid that was displaced. Just to be a little bit careful. So this volume comes into play, and you have to just keep that in mind. Is the entire object underneath? And if so, you can use the entire volume, but if not, you need to use the portion that is submerged.